Today I'm going to give you a very quick demonstration on how to write expressions using exponents. Here we see the factor y being multiplied by itself multiple times. We can show this using an exponent. We see here y 1, 2, 3, 4, 5, 6 times. We simply write this as y to the power of 6, a much faster way of showing y multiplied by itself that many times. The exponent tells you how many times to take the base and multiply it by itself. In this problem here, you see that the base is not just one variable or number, but a little group, a little expression here in parentheses. So what we have as a base is k plus 2, and that we keep in parentheses. And our exponent is how many times it's being multiplied by itself. So 1, 2, 3, 4. So our exponent is going to be 4. Notice that I must put the exponent outside of the parentheses. If I were to write my answer like this, that simply means 2 to the power of 4 added to k, which is very different from this. In this problem, you would do k plus 2 first, then raise it to the power of 4. That's what this is asking us to do. If I don't put the parentheses, I would be using a different order of operation. It would be a different product, different answer. So make sure you keep parentheses if the base has parentheses. In this one, we have multiple different parts of the base. We've got a 5, and there's only one 5, so we're not going to put any exponent there. We've got two r's, r being multiplied by itself 2 times, and then we've got 1, 2, 3, 4 s's. We're going to put all those together with their separate exponents. 5 is being raised to the power of 1, so we don't need to put an exponent if it's just raised to the power of 1. R is raised to the power of 2, s to the power of 4. Why don't you try a few? Pause the video, try these 3 problems, and see if you understand how to write an expression using exponents correctly. All right, let's check and see how you did. This would simply be x to the 5th power. I hope you can see those little numbers and variables on the video. Here, we've got c minus d in parentheses to the power of 2. Did you keep the parentheses? And here, we have multiple different parts of the base. We've got 9, f to the power of 4, and then g. Since there's only one g, our exponent would be 1. If the exponent is 1, you don't need to write anything. Okay? It's assumed that the exponent is 1 if it's not there. Okay, that is it for... Oh, no, I wanted to show you one other thing. I want to show you how to actually evaluate some exponents. And take a look at, I just want to remind you of the order of operations here. Take a look at the concept summary at the top. In order of operations, you probably remember PEMDAS. Please excuse my dear Aunt Sally. However, you want to be careful to understand what all that means. Always use the grouping symbol. Do what's inside grouping symbols first. That could be parentheses. It could also be, we're not going to see this yet, but a problem where you have some operations on the top and some operations on the bottom, something like that. And that means divide. You would do the division last. We're not going to see anything quite like that. But I wanted you to see that grouping symbols are not just parentheses. They could be other things as well. Step 2 in the order of importance are powers. Powers and exponents. And we'll see later on square roots. We're not going to see those now. So exponents are second in the order of operation. Step 3 is doing all multiplication and division. This is very important. From left to right. And then same thing, step 4 is to do any addition or subtraction in order from left to right. And we've talked about order of operations. I just wanted to remind you. So if you look at this real world example here to evaluate the expressions, we've got an example about beach volleyball. The area for beach volleyball includes the playing court and the free zone. Evaluate each expression to find the area of the playing court and the free zone. So here we've got the playing court as a rectangle with an area of 2 to the power of 7 square meters. If we want to evaluate 2 to the power of 7, we're going to do the opposite of what we just did. We're now going to break that down into the factors. This means 2 multiplied by itself 7 times. And a common mistake is to do 2 times 7. This is not 2 times 7. 2 times 7 is 14. This is 2 to the power of 7. Let's evaluate. So 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 16 times 2 is 32. 32 times 2 is 64. 64 times 2 is actually 128, much bigger than 14, and that was square meters. Now, you may have to write some of this out. I did this in my head. You might get to a point where you say, okay, and write it out, okay? Show the multiplication if you have to. In this example, we've got multiple different parts. Some of them have exponents, some of them don't. I'm going to write this a little bigger so you can see. 2 to the power of 2 times 3 to the power of 2 times 5. Now, according to our order of operations, we have to evaluate powers first before multiplying. So it's not okay to do 2 times 3 times 5 and then try to raise it to the power of 2. So we've got to do 2 to the power of 2. That means 2 times 2, which is 4. I'm going to bring down the multiplication sign, do one step at a time here. 3 to the power of 2, which is 9. 3 times 3. And then 5 is just being raised to the power of 1. At this point now, we can multiply in any order that we want because order is not important. Remember, the commutative property says when you multiply, you can multiply in any order. So I am just noticing 4 times 5. I'm going to reorder this. 4 times 5 is 20, and that's easier for me to do because now I know 20 times 9 is 180. Okay, so 180 square meters is the area of the free zone. So that's how you evaluate exponents. Pretty simple, straightforward. We'll practice this in class tomorrow. Make sure you bring your notes, and I will see you then.